Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Faris bin Hasnol and I am from Group IC 5A and I am currently a student that is doing diploma in electronic engineering, industrial automation and control in Unical MSI. And today I want to do a LabView system that is based on a water tank that can be set that can control flow of the fluid and thermal process monitoring for tank system. So let's start. So first you want to add a block called prompt user for input. Prompt user for input. Ui ui. Prompt user for input. This one. Then we have to setting and put our input. I have to mention the names. For example, here of head, and then I'll insert, okay. And here is the temperature. This is temperature. So you can also give any units to it as well, like we can put the unit as Celsius. Meters that was written, or it is all just up to you to just show it. So these meters are the numbers that we can give. Oi. And here is the message: select the maximum. Select the constraints or the boundaries. So now it is set, and now it is giving me the temperature in the head. One point is completed. These values cannot be changed unless the program is rerun again. Those values should be shown to the user in the front panel. I'm going to show those as well. You enter back extra cool. 6% cooler. Maximum coolness, maximum action. My work is easy because I use ClickUp. Here's how I keep track of all my tasks. I start by brain dumping everything I need. So I'm watching a guy right now and trying to follow how to build this fluid and thermal process monitoring for the tank system. So this will be my say go to front panel and then silver, and there I'll show this numeric indicator. We want numeric indicator, we go silver. We want numeric indicator. Just put this will be my temp right, and here it is this, and then I'll make a copy and then dragging it, and then add max. This one is head max. So here it is, like this. And now I can just connect it back with it. So now we connect in the block diagram. Now we can just jump on to our next. We can choose to work the fluid system or the thermal one. And we have an option in here. We'll go to front and then we will go to the layout. Here we'll find out the tab control. So we want the tab control so that we can allow us to switch between the thermal or the switch between the fluid and thermal system. Let's just say the first one I'll choose is the fluid system. So let's put fluid system. And the second one what I'll select in here is the thermal one. So here I can switch between the two windows. I can also remove its label, which is showing me tab control, which has no purpose. So here are the values, the maximum. Here we can select out. Then the next thing is, if the fluid system is selected, the user can specify the inputs like magnitude, the initial head, the resistance, and all those things. So I'll again go to silver and I'll place a numeric value, a numeric control in here. So first thing is, let's just suppose that I am placing in here a input magnitude. You are similarly we can place all the other stuff as well. So for each system we have to set up the step input or an impulse input. The user can see the change for the selected input of the fluid system as a tank indicator and a thermometer indicator for the thermal system. So set this as well.
So for thermal system, do the same also. We just okay, and then boom. One indicator for each thing that we want to represent to change the value of it. So let's change the thermal systems to capacitance. Here we want to change to resistance. Make it a bit bigger so it's visible. And we for temperature input, you get a bit bigger as usual. And the last one is initial temperature data.
So for that purpose I will go to silver, and then again we have different options sections, but again
So for thermal system we want a thermometer. So let's just put thermometer here. And let's make it a bit bigger. And then we want to add a digital display.
silver ones seems a little quite a more ones as perspective, so we can also show its digital display as well, right? So it will be look better. So again, for the fluid system we have to show a tank in here, so again I'll open it and
So
go
fluid
to
system,
silver, and
let's first change the name of the thing first of each. First is magnitude, and we want initial head. Then resistance. And then capacitance. Capacitance. Let's add a labeling here so that we won't get confused later in front panel, because we will be because there is two capacitance. So let's put C, and then we put F for fluid system. Here can add F also. So here can add T, here also add T. Okay, now here let's move this a bit up. Can add tank for the fluid system. We want it to display.
And instead of silver, this time I'll go to system. Here I will find out classic tank, which looks more better than normal one.
Oh, we want classic
So
tank.
here I'll again increase its size. I could
My
give
god.
the two inputs in
So
here,
we
the step input or the so must have to select something in here. We must have to
so we
set
want
out
step
something that we can select either it is step or impulse. For
and
that purpose again
impulse,
I'm going to
and
classic,
then we
and
want
here
to
I
add
could find
a
out about this horizontal switch. So I can step or impulse. For that purpose again I'm going to click, and here I could find out.
we want horizontal switch. So and we put step. Let's make we put like here. Plus we put here, and then we group them so that if they move, they can move together like this. Then we just copy again.
So I can just place this out in here. Let's just say this. I'll write right. Right
Select.
here I can do one more thing, like I have to mention which one is step in. So I'll just simply write step, then I'll write impulse. Let's just say the off side of the switch is our step input, and when it turns on then it shows us the impulse, that it won't move. Like I try to move this whole switch, this will show me the whole step input and impulse both together. Also show this as views icon.
So we are
This.
done with front
So
panel for now.
this one is for
So let's
fluid,
go to
this one
block
is for
diagram.
thermal. For fluid, and have a tap control in here. Initial head resistance, magnitude, head resistance. Our fluid resistance one will be our system.
So let's see this. This is our fluid system. Okay. And then capacitance fluid system, so F, and the resistance F. Right? our block for the thermal process monitoring system. Others right here. Can move a bit right here.
So structure.
We need to add case
So it will
structure.
switch between the fluid or the thermal ones inside the fluid. Get it. One thing we can place it.
We want a one loop for you.
Instructions we have to make weight, which is like weight a constant.
Hello. Okay.
2000 is like 2 seconds, increments of 0.2 seconds. So we will place a weight which
So
is
we want to have 0.2 second time. So we use weight block. MS at constant is 200 because we want 0.2.
like the constant. 2000 is like 2 seconds. So if we increase it, so now it is like 0.2 seconds. Then what I need to do is in here I have a pulse input or step input or an equations depending upon the selections. So here it is the thermal ones. So again I'll shift back to the fluid. So first of all I'll build up the
So let's start with fluid system first. Let's do the system. So for fluid, thermal fluid. That one, that one is fluid. Let's just change so that easy to recognize.
equations. So I'll place a case structure.
So we need
So
another case structure inside.
so now section we have, I will also show you again. If it is true then it is impulse. If it is step. Right now it is true. Then we write down the equations for the fluid system step input or input. So now I have just shown model, which is quite a simple thing.
So now we have to build a mathematical model. Okay, so let's try. The hierarchy structure. Non multiply. Multiply we want 1, 2, 3, 4. 1, 2, 3, 4. And then we want is the reciprocal. 1. And then that's divide. Divide. Then negate. 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 Then we want exponential block. Exponential. Then add. Add is last one, so we can put here. Okay. Now we can try the wiring lah. Let's rearrange so it can be easier. Capacitance. Oh, you have to change the control, I think. Right.
The fluid systems, then is quite a simple.
My system. Now we can do wiring. Okay, temperature input. We go into this X. Let's move a bit so be nicer like this. And then resistance to here. Then capacitance into okay. Then initial temperature. Okay. Here. Then reciprocal here. We go into here. here. Here we go here. Then X, what? Make it go here. This. Okay. Uh, this we need to go here. Then this will go here. Plus we go to X here. And then this
simple thing to do. So here, as
for false, multiply again. Only multiply 1, 2, 3. What is that? I guess it's divide again lah. Divide, right? This one is what thermal system force.
that we have to build a mathematical model, which is quite a simple thing to do. So here, as for true and false, about the
Multiply. Okay lah. Okay. We add exponential block. Should be around right. I think it's correct again. So temperature input, resistance, tap control. Okay, okay. Now capacitance will go to here. Okay, and then this will go to resistance, and then go into here. Then this will go into here. Okay, and then the divide will go into the negate. Okay, the one right. The negate will go into exponential, and then the initial temperature will go here to the multiply block. Then here will go into the wait. This go here to multiply block to the bottom part. Then this we connect here. Then this we will connect into bottom side of negative. Like this, I think like that, if I'm not mistaken.
I have just connected out the pins and I have built a simple model. Done in here is simply I have equations for the fluid
System.
and I have built a simple model.
We'll go into the fluid system. It's very confusing. System. I think that is reciprocal again. Then we want add apply compound arif, and then reciprocal, and then another multiply. Then is that divide? Divide, negate again, negate, divide. Is that maybe So let's just do first. See if it works or not. Let's connect this here. Then let's connect. Let's first connect this one first. So this go into capacitor capacitor. Okay, capacitor, and then go to. So we need to change the arithmetic first. This mode we want to change into multiply, and we want how many? 3 3, and then this will go into reciprocal. In this magnitude to plus to go to plus. X also go to plus. Oh my god, X also go to plus. And go here. Okay. What? Oh, I think no, wait. It's wrong. Let's go here. Go to plus. Then magnitude go to second. second. Initial head terus masuk X ni. Okay, then this masuk dekat thing, and then okay, dapat masuk sini. Local. Should be finish for the true situation, I think.
So now what I have done in here is simply I have drawn the equations for the fluid as well as for the I have just connected it with this inputs. You can also do something if you are like morely use tab or like something, then you can use a formula node, and then here you can inputs, add an input, and then you can define as temperature input as a whole name, then it will take as an
So now we need to do first one. Multiply to divide. I think that's divide. Should be divide. 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 And then negate, I think. Negate. And then exponential. Exponential. Boom. And then multiply again. How many? 2. 1, 2, minus, and plus. No, add. Okay. Now we want to rearrange. So let's put it here. Make it put here. Put here. Let's put here. Now we do connection again. So capacitance will go here, and then this go to resistance. resistance, and then is going to divide, is going to here, then divide go into exponential, into negate, then this go into exponential, negate go into exponential, and then this go into bottom x, and then here go to the bottom of the x at the bottom. So here x you connect here as well. Ay ay. So connect here. Okay, and then x we should connect to initial temperature data. Why you done this?
Input here it so and system and system show it in here. Imagine conducting every part of your research only on one platform. Meet Boreum, your AI-powered research companion. With 170 million papers, 140,000. We want to
Wait, system false ya, ya Allah.
the equations. A simple thing about this connected it with add an you can define as temperature input as a whole name. Then it will take input in here. Then here left one is so here we can reset it as well as and elongate this one show it this so here we can reset it as well once or come in here so we can
I guess
by RC so to T divided by RC in here we must have to bring out something new we
we add the last time.
are using some elapsed timing here right
How many seconds?
elapsed time of 0.
Zero
Right
point 0.2
now
seconds.
time is in here so again in here so I'll connect our system. So now we can also set it by creating.
So you wanna reset kan? It's a bit bigger. Set.
We can so here we can reset it as
Then we can go
place
front
that
panel.
here, and we can also replace it with something silver ones. So here we will find out refresh. We can say reset or reset. So here we can reset it as well as so place that in here, and we can also after setting this we can also replace it with something silver.
So okay, so we want to replace with refresh button. So let's go refresh boolean.
Go to boolean, go to and
Place silver boolean button refresh.
there we will find out a refresh button. Instead of saying refresh we can say reset or reset, like yeah, reset time or anything like reset time, right? So and again just go back in here, and now what are so if we come in here we have now all these things, and now show it into a temperature. If it's system and it is a thermal system, connect that in here. We have now all these things,
So
and
now
now we want to show it into a temperature. If it's system and it is a system,
thermal system. Okay, thermal system. Boom. Thermometer. Boom. What the heck? Ah, still the one loop. Okay. Okay.
system I will show it as a
Okay, and then we what? Tang. Okay. So here also we need to create control also.
zero. Now we have created this system, but still it is not because of
Wait. Constant. Ay, ay, ay. Create constant, not control. Okay.
This error that we have not connected. So warning message should appear if the temperature or the head reaches more than
Warning
70%
message should
of the
appear if the
allowed
temperature or the head
values.
reaches more than 70% of the allowed values.
So here the allowed values are here. Still we want to running this system.
Okay, so let's put, okay. Oh, we need to add flat sequence pula. Flat sequence. Oi, oi. Very complicated ah.
And add a frame before.
Add frame before.
I'll this and put it in.
Okay.
As this structure is not completed, this won't start out. Obviously, these values will be pop up. You can see these values, and after ending out, we need to do something else as well. In the frame after, we need to reset out all these values, right?
Application controller.
Need to reset out all these values, right? So control
VI server reference.
this VI it all values initialize
So create method for VI class and then default values. The reinitialize all to default.
this as a reference so that after we have completed all the system, all the values will be reinitiated set to zeros or the initial levels. One more thing is in here, have to show the maximum if they are exceeding 70% of maximum values, then show a warning message, right?
Oh, we need
So
warning
for that
message.
purpose, what I'm going to do in I'm going to
to make the while loop a bit bigger.
Values, then we need to show a warning message, right? So for that purpose, what I'm going to
Create
use a property node.
property node value.
Similarly,
Property node same
value.
value. Hello?
I'm going to use this divide function.
Divide function.
Instead of divide, also say
Please multiply. Okay.
I'll multiply that with 0.7. Means we are considering just only 70% of the value, only 0.7.
So okay, so we want this to become 0.7 0.7 because we want only 70%. So we want to create a constant which is 0.7, which is also known as 70%. 0.7 known as 70%.
Since we are considering just
So we
only
can do the same for this one
70% of
also.
the value, right?
Create the control.
So
Constant
if these values are like greater than
0.7.
temperature, oops, not maximum.
So greater than, need to increase again. Greater than greater than greater wrong. Is here.
And again, like system,
Then for the fluid system same also. Copy, paste, then we put here. Then here we put head max.
head. Again, I'll show something. Then select function, use the select and then well. So
Select function. Select function. Woohoo! Select. Select.
now
Oh, need string constant. Holy. It's not for to give the message. String constant is used to to show what we want to write if a certain situation is met. So to write
false, I would say to reduce its size.
to system. There is warning above. Warning above 70% max temp. I mean it's long message ah. Make it smaller lah. Can put here.
Size so that it will fit within the screen. As false system here. Similarly, I would make a copy out of it. Here, this time I would say fluid system and add
We do the same thing but for below also for the string. Oh you Control C then max head. Fluid system.
right in here. So now I have the two outputs, but still I want to show it on output panel. And here
So we go front panel again.
silver, and then again
So we want string indicator so we can know the status of the
like this label on the button is show it in here. Justify to center so that all the message will be centrally aligned. So I'll structure in here and I'll
so we go back block diagram. We need case structure.
connect that with this tab control.
So tab control again. It's a long connection, no?
fluid system.
It's the stream. Yeah, stream.
And for the should be passed to this one. Should be connected. String output. We can have the both messages. Now what are the next requirements we have?
Thermal system ah.
The thermal ones should be connected. Only one string output. Have the both messages. Now what are the next requirements we have? User should be able to reset, right? So here we have already set that time. I could place that. The next is the program will be stopped if one of the conditions is met. The maximum temperature is reached. All right. Reach if the program for a specific input has run for a specific time target. The user clicks a safety button. So again, place a safety button.
So we need to add safety
We can
button.
choose it from the silver ones, boost, and let's just say stop our safety button. Size equal. Also align them. Label. Properly align in here. So this will also close it, or the maximum value. Here I could use numeric and the compound arithmetic and set its change the mode to or. We have multiple conditions in here. So we have greater than or equal to sign for the maximum temperature. Conditions in here.
Go back to plot
This will
diagram.
also close it, or the maximum value. Here I could use arithmetic and set its change the mode to or.
Compound arithmetic ah. Change to or.
Conditions in here.
3 input, so let's
Sign.
greater or equal.
The maximum temperature. we'll give this a
So what? Thermometer. So here, from here. Here we go here. Here we go into here.
Again, we have to compare it with the maximum head. It automatically grabs the wire. Yes. So we can take a wire because it is connected to in here. So we have these conditions in here, and then the other condition that we have the stop button as well. That back. And just connect it in here. We have one more condition that if particular system is run for a particular time, then it should also stop. So let's just suppose that our elapsed time in here, set it, let's just say comparison.
Okay, so we need greater than.
We set it, let's comparison. Let's just say if it is run for more than 2 seconds or 2 seconds, because right now elapsed time we have set 0 0.2, so seconds or like minutes, then we have to add one. Then we can also connect that in here. Similarly, give it into the fluid, select it, then we have to add 0. then in here similarly we have to give it into the fluid system as well. I will make
Okay,
a
we give
workout
to
of it
thermal and fluid
and
already.
I will select it so that for a particular system we can also change its values. So let's say
For fluid system, let's change out 1 minute.
for 1000 supposed to be 1 second, for the 10 seconds, not for the 1 minute, it is just 10 seconds and it is just for 20 seconds. Single one, and now it's back. And if I run my system in here, so first
So
thing
should
it
be
asks
done.
me about the temperature input. I would say the 30 is my temperature.
Fluid system false. Hah, semandoi. System false. Just save first ah. Hai yui. Macam mana doi? Is it the same ah? Macam mana ah?
The copy out of it. Also on the
What's the matter though? So let's try something lah. Let's try something. Wait. Tak boleh juga tu. Force ni macam mana tu? Sistem mana force tu? Oh my god, what is this? Okay, so if I just have everything wait to the output tunnel. Okay, so does not have anything wait to the output tunnel in one or more cases. It's only one flow to strategy affected.
so that
But fluid system false. Okay, here we go again. Okay, then the times so it's 2, okay, times atas masuk resistant, bawah masuk capacitance. So it's right lah. And okay, X ni masuk ke dalam initial temperature. Ya, initial head kot. Then magnitude active masuk ke dalam maybe like this ah, maybe ah. Not sure. So let's try and run lah. So let's say uh 30 that. So let's say one see basically how the system works. So okay, so magnitude we put our head max 10, right? So here our fluid system, if you put 8, look, it has the warning above 70% max head. So the system basically detects the water tank level, if the water tank level in the water tank, how can I say? If the water tank level, if the head level is exceeding a certain threshold that we are setting, in which in this case we put 10. So if it goes above 10, then the system will stop automatically or will reset. So like this, then it will reset. It will stop lah if before the water will overflow. So for the temperature, let's say we put 50, and this we put like 10 again. For thermal, let's say we capacitance put 2, 2, and then 2. So look, so when the temperature input 50, right? So let's put. So you see the system is still running. The water tank temperature is still not exceeding the threshold, which is 50. And now when it's on 35%, it is 70% of 50. So it is above the 70% max temperature. So it's approaching the danger zone for the system. So when we put 50, our system should stop working. Boom, it will stop work. So basically it's a safety. The system is for safety like safety mechanism for flowing of the fluid in the tank and also for the thermal temperature for the tank. So we also have this reset time button. This, this reset time button, so we reset the time from 0, so we start from the beginning. And also for safety button, it will stop everything and we can start again from the beginning. So that's basically how the system work in the practical test. So thank you for watching, and I hope you understand what I'm trying to say. So I think that's it. That's it. Wait. Nothing more, right? Everything is working as expected. So that's all from me. I hope you understand what I'm trying to say, and thank you so much. Assalamualaikum.